In this video, we are going to discuss some applications of quadratic functions. So, applications of quadratic equations. The first one we are going to talk about is projectile motion application. This is a famous application. Anytime we throw an object into the air, it follows a parabolic path. It goes up for some time, then it starts falling down, the gravity pulls it down, and finally it reaches the ground. So in this example, the ball is thrown downwards from the top of a 180-foot building. So somebody is standing at 180-foot high building. The ball is thrown with an initial velocity of 20 feet per second. The height of ball h after t seconds is given by the following equation. So this is the function representing height as a function of time. That means height is a dependent variable and time is an independent variable. Height changes as the time changes. Okay, so we throw a ball and it's going down. It goes up for some time, then it starts going down. Part A of the problem says, after how many seconds does the ball reach the ground? So ball reaches the ground when the height is equal to 0. So I'm going to start by the function h of t. H of t equals negative 16t squared plus 64t plus 200. When the ball reaches the ground, and we can add ball reaches the ground when the height is 0. So I'm going to replace the height by 0 and go ahead and solve this equation. Negative 16t squared plus 64t plus 200. Now, to make my life easy, I can go ahead and divide both sides with the same number so that I don't have to deal with the bigger numbers. I'm going to go ahead and divide everything on both sides with negative 8. So divide with negative 8, negative 8, negative 8. And my new equation becomes 2t squared minus 8t. And 25 divided by negative 8 is negative 25. Now, I'm trying to solve this equation for t, and I don't think it's factorable. It doesn't look like factorable. I'm not going to bother. I'm going to go ahead and do quadratic formula because it always works even when the equation is factorable. And this one is definitely not factorable. So t equals negative b plus minus square root of b squared, negative 8 squared minus 4 times 2 times c divided by 2 times 2. So t comes out to be 8 plus minus square root. 8 squared is 64. Negative times negative is a positive. So that's a plus positive. 25 times 4 is 100 times 2 is 200 divided by 4. So t comes out to be 8 plus minus 264 divided by 4. Let's go ahead and use the calculator and find the two answers. Once I'm going to use the positive 8 plus square root of 264 divided by 4. And that turns out to be 6.06. 6.06. And the other answer, I'm going to have to replace negative sign in the middle. 8 minus square root of 264 divided by 4. That turns out to be negative 2.06. So I get two answers, negative 2.06 and 6.06. I know time is never negative. So distance and time are never negative. They're always positive. So I would say that negative 2.06 is not okay. My only answer is t equals 6.06 seconds. And that's the end of this problem, part A. So after about 6.06 seconds, the ball will reach the ground. Okay, 6.06 is the answer to part A. Now we're going to look at part B of the problem. Part B, how long after the ball is thrown it will be 50 feet above the ground. Now we're trying to figure out when is the height 50 feet. Because as I can see, the ball went up for some time and then it started coming down. And at certain point, the height will be 50 feet. And that's the time we're trying to figure out, or what time the height is 50 feet. So I'm going to go ahead and replace the height by 50. 50 equals negative 16t squared plus 64t plus 200. And now I'm going to go ahead and take 50 to the other side. So 0 equals negative 16t squared plus 64t minus 150, because actually plus 150 because I subtracted 50 from both sides. Now dividing both sides, I don't think I can do with the 4, so I got to divide everything on both sides with the negative 2. Divide with the negative 2, negative 2, negative 2. So my new equation becomes 0 equals 8t squared minus 32t minus 75. And now it is time to use the quadratic formula. T equals negative b plus minus square root of b squared minus 4 times a times c divided by 2 times a. A little bit cleaning up, simplification, 32 plus minus square root. I think it's going to be 3494. Let me double check. 32 squared minus, actually it's going to be plus because negative from negative will be a plus. 4 times 8 times 75. 3424. 3424 divided by 16. Okay, now I'm going to use positive sign ones and the negative sign ones, and I would be able to figure out the t when time was 32 plus square root of 3424 divided by 16. Looks like that is 5.65 seconds. So there's 5.65, and the other time I'm going to use 32 minus square root of, most of the time the answer turns out to be negative, but it can be positive sometimes, so it's important to check. In this case, I know it's going to be negative because the ball started at 180. So before the time 0, sometime before, negative 1.65, which is not okay. So my final answer would be 5.65 seconds. So we can say the ball would be at 50 feet after 5.65 seconds it is thrown. That was all for this problem. It was a projectile motion problem. Here's another example. The holding pen for cattle must be a square, so I'm told that it's a square. It's got a diagonal length of 100 meters. Find the length of side of the square. So for this problem, I did draw the square, and I'm told the diagonal is 100. I don't know the side of the square, but I know whatever one side is, the other side is going to be same. That's a property of square, that all the sides are equal. So and also square has right angles. So I'm going to use Pythagorean theorem here. Pythagorean theorem says leg squared plus leg square equals hypotenuse squared. And this is hypotenuse in this case because your right angle is pointing at hypotenuse. So x squared plus x squared is 2x squared equals 100 squared. That would be 100, 2 more zeros. X squared equals, so we're going to divide both sides with a 2. That's going to be 5,000. X squared equals 5,000. X comes out to be plus minus square root of 5,000. Now, one thing I do know, that length of the square cannot be negative. The length is always positive. The distance is always positive. So we're not going to go with the negative answer. We're only going to go with the positive answer, which is 50 root 2. Or square root of 5,000. When you simplify, it is about 70.71 meters. Don't forget the units. So the length is about 70.71 meters approximately. If you want to give exact answer, then 50 root 2 meters is my exact answer. Next example, Virtual Fido is a company that makes electronic virtual pets. The fixed weekly cost is $3,000 and the variable cost for each pet is $20. Let X represent the number of virtual pets made and sold each week. So each week we're making X pets. Write the weekly cost function C for the Virtual Fido. Okay, C equals 3,000 plus 20X because this is your fixed cost, this is your variable cost. Because we're making X virtual pets, so cost from those will be 20 times X, 20X. Because each pet costs $20. So this will be a weekly cost function. Next part, the revenue function is given to be negative x squared plus 1,000x. Revenue describes the money that Virtual Fido takes in from selling X pets. Write the weekly profit function using the cost function and the revenue function. So profit is equal to revenue minus cost. So your profit is all the money you brought in minus everything that it costed you to get to that money. So revenue would be profit. I'm just going to call it P, profit P. P is equal to negative x squared plus 100x minus the cost function. We just wrote it on the last page, 3,000 plus 20x. So 3,000 plus 20x. And that leaves me with negative x squared plus 100x minus 3,000 minus 20x. Now I'm going to try to combine the like terms, and that's my P of x, profit from x pets. P of x is just, profit is a function of x, where x is the number of pets. Negative x squared, so we would have 980 positive 980x minus 3,000. Next, find the maximum weekly profit and the number of pets that would maximize a profit. So maximum weekly profit and the number of pets that would maximize a profit. So to answer this question, you have to have a little bit, information on the graph of quadratic function. So your quadratic function parabola looks like this. Because it's a negative coefficient, the first number is negative, it's going to be a downward parabola. So at certain point, you do have a certain point where your profit is maximum, and after that point, it starts coming down. Okay, so we're trying to figure that point where the profit is maximum. And in terms of graph, this is called the vertex of the parabola. Vertex of the parabola. Okay, so vertex of the parabola is what we're looking for. And to find the vertex, to find x coordinate of the vertex, there is a formula negative b over 2a. So it's going to be negative 980 divided by 2 times negative 1. That's going to give me how many pets a week will give me maximum profit. So 980 divided by 2 is 490. So 490 pets per week will give you maximum profit. Pets per week will give us maximum profit. Okay, 490 pets per week will give us maximum profit. And we also want to find out what is that maximum profit. How much is that maximum profit? How much is that maximum profit? So to find that out, we are really trying to figure out what is the profit when x, how much is the profit when x is 490. So I'm going to plug 490 for x in here and find out what is the maximum profit. So go ahead and plug P of, okay, P of 490, that's going to be negative 490 squared. The negative is not a part of the square. 980 times 490 minus 3,000. So let's start plugging into the calculator. Negative 490 squared plus 980 times 490 minus 3,000. And that turns out to be 237,100. Okay, that's it. 237,100. That's the maximum profit, and it's in the dollar sign. Don't forget the dollar sign at the front, because the units for profit are dollars, and the units for X is the pets. Okay, that's all in this video.